Electric potential. Before working on this video, you will need to know the relationship between work and potential gravitational energy. If necessary, you should refer to the video indication covering this topic. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. You have already learned about the relationship between work and potential gravitational energy. The work is done when a force moves an object in the direction of the force, so that W is work, F and D are the magnitudes of the force and the displacement of the object. In a gravitational system, lifting a mass a vertical distance against the Earth's gravitational field requires work. The work is a conservative force. The work done against the gravitational field increases the gravitational potential energy of the system by amount equal to the work done. Mathematically, we can write as follows. Similarly, in an electrostatic system, moving a small charge through a certain distance against the electric field produced by another point charge requires work. Since the force required to do this work is also a conservative force, the work done in the electric field must increase the electric potential energy of the system. We now will study the uniform electric field between two charged parallel plates to introduce the concept of electric potential difference. We can set up a uniform field between two parallel metal plates by connecting them to the terminals of a high voltage power supply as shown in the figure. If two parallel metal plates such as those in the figure are oppositely charged, the electrostatic forces of repulsion of like charges within each plate cause the charge to distribute evenly within each plate, and electrostatic forces of attraction of opposite charges on the two plates cause the charge to accumulate on the inner surface. Thus, the charges spread and distribute evenly on the inner surface of the charged plates. The field lines run parallel from one plate to the other, meeting the plates at right angles, except near the edges. The field between the plates is uniform. This is because the electric field strength has the same magnitude and direction everywhere between the plates. This means that the force experienced by a small test charge placed between the plates will have the same magnitude and direction wherever it is placed. Let us suppose a small positive charge in the field between the plates moves from the negative plate to the positive plate with a constant velocity. This motion requires an external force to overcome the electrostatic forces the charged plates exert on the positive charge. When work is done against the electric force, the electric potential energy increases. Recall that work is force times displacement. We now divide both sides by charge Q. The ratio of force to charge on the left is the electric field. The ratio of energy to charge on the right has a special name, electric potential difference. Electric potential difference is commonly referred to as just potential difference or voltage. By definition, the potential difference between the plates is the electric energy stored per coulomb of charge. A pair of parallel plates at a separation of 80 mm are connected to a high voltage supply unit which maintains a constant PD of 6,000 volts between the plates. Calculate the electric field strength between the plates. To calculate the magnitude of the electric field between the plates, use the equation and perform the calculations. Calculate the magnitude and direction of the electrostatic force on an ion of charge 4.8 times 10 to the power of minus 19 coulombs when it's between the plates. The force on the ion is directed towards the negative plate. To calculate the magnitude of the electric force, use the equation and perform the calculations. A cathode ray tube computer monitor accelerates electrons between charged parallel plates as shown in the figure. These electrons are then directed toward a screen to create an image. If the plates are 1.2 times 10 to the power of minus 2 meters apart and have a potential difference of 2.5 times 10 to the power of 4 volts between them, calculate. The electron field strength between the plates. To calculate the electric field strength between the plates, we use the formula. Calculate the force of an electron in the tube. To calculate the force on an electron in the tube, we rearrange the formula. And the electric force is the magnitude of the electric field times electron charge. Calculate the work done on the electron by the electric field when it moves from negative plate to positive plate. The force as well as the acceleration will be constant and opposite to the field lines. The work done by the electric field to move an electron between the plates can be calculated rearranging the formulas. Calculate. Assuming that all this energy is converted to kinetic energy of the electron, calculate the speed of the electron when it reaches the positive plate. To calculate the speed of the electron when it reaches the positive plate, we use the work energy theorem. The initial kinetic energy is 0. The next problems are from past tests, and the solutions are self-explanatory. You should try to solve them yourself, and then check out the solutions. But if you have any question, feel free to ask or suggest anything.